yesterday we started the 1/6 and we started the language that we're going to be using for the rest of this chapter, relating it back to the quadratics, right? So we know that outside here are vertical and inside the bracket is horizontal. I'm going to keep using that idea. In the bracket, so in the squared part, that's talking about the horizontal transformations. Outside here are vertical. Okay, so when we have something like this, the outside portions are going to be vertical and the inside portion here is horizontal. So let's note that down. So this is our 1.6. We're just finishing up this. So this guy here, this is vertical, and this one here, anything outside here are vertical. Everything inside of the bracket, so everything inside of this bracket here, this part here, this part here, this is all going to be horizontal. So in the bracket is horizontal, the two outside bits are vertical. What that means is that, look, when we looked at the parabola, right, they're quadratic, inside here, this was a shift to the left or right from the x, right? So that's horizontal transformation, and translation. And then out here, this is going to be a vertical reflection, a flip, right? Opens up or opens down. And then here, this was moving the graph up and down. So outside around it is always vertical, and inside the bracket always has to do with horizontal. That's the idea we were looking at here. So outside was vertical, inside the bracket is horizontal. You're always starting with that. Outside here, the 2x squared, the 2, that's vertical. Inside the bracket will be horizontal, so in the squared part. Outside here is the vertical reflection, right? And then if I put it in the bracket, it's a horizontal reflection. Okay, now, these are all of the ones we talked about at the beginning, 1/6. My note here is, when graphing, always perform the translations last. Or when you're actually performing any transformations at all, you always want to, so the key part here is that the translations go last. What do I mean by translations? That's the shift. The shifts are last. Right? When you shift it left or right or up or down, that is always done last. The way you can think about that is that multiplication goes before addition, subtraction. So the shifting, the left, right, up, down, is always going to be a plus or minus afterwards. You always do everything else first. So this is because if there's reflections or dilatations, right, so stretch and shrink, the translations will exaggerate them. The answers will end up being exaggerated. So you want to do the stretching and shrinking and then move your graph. If you move it and then you stretch and shrink it, you're going to double and triple it, right? It's going to be affecting the shift. So order of operations says addition, subtraction last. That's what we want to remember. Okay, and that'll be the same forever. All right, so let me do this. So we're going to look at this as we're doing the graphs. Okay, so if the words don't quite make sense, we're going to do a couple graphs together. Yeah.
So are we going to have like 2 graphs?
I'll show you in a second, yeah. Yeah, there's 2 ways to do it, so you can either do 2 graphs or a chart. I'll show you, yeah. Okay, so first of all, let's look at these concepts one more time, and we're just going to take a point. So without doing the full graph, we'll do a full graph in a minute, but we just want to practice on a single point. So let's see if we get it. We're just going to move this one point first. When I have, also to point out, today, we're just concentrating on the new one. So in 1.7, we're only investigating the horizontal stretch, compression, and reflection. Not even the shift. So we're not going to do the shift today. We're going to do that in 1.8. Okay, so they're just saying, wait, can we just concentrate on the slightly new stuff? Yes. So what was the newest part on our chart here? This one here. We never did a in the bracket and in the bracket here, the reflection, okay? Then we did do shift, right? We did left, right, up, down, so they're saving that for the next day. So today, all we're looking at is horizontal stretch, compression, and reflections, just the new one, and then we'll put it all together in the 1.8 section. All right, so here, if I have this 1 point, so again, it's just a single point. They didn't do the whole graph, but let's practice on 1 point on the function. They didn't name the function. They didn't tell me if it's x squared or square root, whatever. They don't care. Just let's practice on a point. State the coordinates of the image of this point on the graph. Where did this point get shifted or moved to, right? Where is this point getting transformed to? So here. When it's f, f is standing for the general function, just the general. I don't know if it's x squared. I don't know if it's square root. I don't know what it is. They just said in general. Where would this point be moved to? So f stands for in general. Right, so I'll zoom in a bit. So F stands for in general. We don't know which function is, doesn't matter. It still works the same way. If it's in the bracket, you're going to hear me say this so many times. In the bracket means horizontal. Okay, anything in the bracket is horizontal. So in the bracket means horizontal. So in the bracket means horizontal, right? And we're going to recognize that because at 1.8, I'll put stuff outside of the bracket, right? So I'll put it in front of the F, after it. So in the bracket means horizontal. So I see it's in the bracket, so right away I know that this means horizontal. So in my brain I go, oh, in the bracket means horizontal. You don't have to write that, but just what my thought process. Now, in the bracket is always the opposite. So remember the parabola. If I say in the parabola, we're going to move it, and I said to you, I just try to relate it back. X minus 2 squared, that means I'm going to move it which way? Right 2. Does that make sense? Right 2. It's opposite. We've done that before. Today we're looking at this. Okay? So this, instead, the opposite of times 3, reciprocal. Okay, so again, it's not just the opposite sign. That's the shifting. That's the left-right. That's what we did before last year. Now we're looking at what if I multiplied it? Multiplying it, we're not going to do minus because that doesn't make sense. The opposite of multiplying by 3 is the reciprocal. So this is actually going to multiply it by 1/3. So it's going to be as third as wide. So we're not stretching it wider. We're making it as third. Now, I don't know what the function is, but we know that that point itself would be a third. So I'm going to make an equation. So I'm going to say my x, my new x, and the way I'm going to do a new x, my transform x, is do a little subscript, t. Subscript t, xt. So my transform t is going to be 1/3 times my original x. So I'm going to make another equation to say, okay, I know what's going to happen to my x. My x is going to be a third as wide. Right? So it's not times 3, it's a third as wide. So not as wide, it's going to be less. So then I take my x value here, which I have given to me, right, 2, 5, like that, and we're going to sub that in for my x, and that's my y. So then I take that, and I'm going to sub it in. I'm going to go 1/3 times 2, which gets me top times top, bottom times bottom, so 2/3. Now, what happened to my y? Nothing. Okay, I didn't do anything to my y. I only have a horizontal transformation. So my yt is still just y. Nothing changed with it, so it's just still going to be 5. So then that means, okay, that means that my point went from 2, 5, and it's now being mapped. So you can put an arrow, and it's being mapped to 2/3, 5. So this point has now been transformed to here. It's been mapped there. You don't have to put the arrow. If you want to just put therefore 2/3, 5, that's fine. Right? So you don't have to put this, but this is telling you that this point has now been moved here. So it's an arrow, not equals. So it's been mapped there. Yes, question?
So where does 1/3 come from?
It comes from whenever I have a horizontal, it's the opposite when it's in the brackets, and actually make it a third as wide. So it's not a shift, it's actually you're making it less wide,
So
the graph.
Yeah.
Okay, yep.
Wait, so we're just taking 3/1 and just flipping it? Or like
Yes, always. So think about the parabola. So I'm going to bring this back to the parabola. So watch this. Wait, watch. Okay, so if I have this, that too is inside the bracket, right? So what happens is that if I have my xy, 0 is not going to affect anything. 0 I put in is still 0. What about 1? When I put in 1, normally I would get 1 back, right? 1 squared. So if this was my regular, we know our parent function, x squared, right? 1, 1. What if I put 1 in here now? 1 goes in, 1 times 2 is 2, so it's 4. Does that make sense? So it's 1, 4. I put 1 in there, 2 squared. What if I put 2 in? So 2 in, 2 times 2 is 4 squared, 16. So what's happening to my graph, okay, my parent function again, look, is this regular shape. This is 1, 1, right? That's 1, 1. What happened to my graph? Instead of 1, 1, it's at 1, 4. Instead of at 2, 4, it's at 2, 16. So my graph becomes half as wide. So this 2 here, whenever it's in the bracket, is actually making your graph half as wide. So this 2 makes your graph thinner. Okay, so anytime it's with the x, it's not making your graph wider. So when you think of horizontal, it's not making it twice as wide, it's actually making it half as wide. So when you try the values, these values will all be shrunken in by half. Okay, that happens for the problem. It actually happens for every function. So they're just saying that for every function, this pattern will hold the same. Yes?
Why is it like y is equal to f of x? Because I thought like f of x is supposed to...
F of x is the parent function. So that's the regular f of x. But I want you to transform it now. So I want f at 3x, which is telling me that whatever the function is, I want it to be 3x. So that's like saying this one here, I want it to be 3x squared, right? Or I want it to be square root 3x. Or I want it to be, so the f is standing for the new function, whatever the function is. And I didn't tell you what the function is. I'm just saying in general, the same pattern will hold true. Whatever value I have, it will become the reciprocal of whatever the width is. Yeah? No, try it. Look at it. It literally is not. Okay? So try the value. Then you're, yeah, but that is different. That is different than this. Mathematically, are these the same? No. What is this? That's 4x squared. That is not the same. Put in a value. It's not a trick. It's literally put in a value. When I put 1 in, it stretches. It'll be 2. That's a vertical stretch by 2. Put in 2. 2 squared, it'll become 8. Graph it, it's a vertical stretch. So this one here, it's half as wide. So it's half as wide, which is a vertical stretch, but you're connecting the two. So I want you to concentrate on the horizontal part. How much thinner is it here? Yes, it's equivalent to a vertical stretch, but I'm asking you to concentrate on the horizontal part. How wide is it? Okay, so concentrate. They're different, right? So if you make this into a vertical, that would be 4x squared. So that would be a vertical stretch times 4. So just concentrate on leaving it where it is for now and talking about it horizontally instead of vertically. They are equivalent, but then you have to simplify this. And not every function can be simplified. That's the problem, is that if you always want to convert it to vertical, what are you going to do with this? You can't take it out, right? So then you're going to be like, okay, but I want to take it out. How do I factor it? Then it becomes more complicated. So leave it in. This is a horizontal shrink by a factor of 1/3. So leave it where it is so you don't have to simplify it every time. Right? So that's what's different from last year. Last year we always just said simplify it, make it all vertical. Now we want to leave it where it is so we can talk about things horizontally and vertically. And a horizontal compression is a vertical stretch. So they are equivalent, but we want to talk about it this way. Okay? But you're right. So it's a vertical stretch, horizontal same, but I want to talk about it horizontally instead of vertically. Right? So today we're concentrating on that. Yes? How I sub in, I want to do top times top and bottom times bottom. So 1 times 2 and 3 times 1.
Yeah, but what's with the... What did you put next to the x? Because when you did x equals 1/3 x?
Yep, 1/3 x. That's a t. 1/3 times x, that's times.
Okay.
So when they're beside each other, it's multiplication.
No, I mean, like, the x before the equal sign.
Yeah, xt, right? I said t, like capital T, capital T. Yeah.
So, if instead of it was like f of 3x, if it was like f of 4x, would it be 1/4 instead
Yes.
of 1/3?
Yep, so let's try it again right here. Okay, so try it again. Yep.
How about when in a parent function we got a like fraction, like for example 1 where 3?
Yes.
Are we switching back to like just a 3 or like what is it?
Yeah, so if it's 1/3, we put it to 3. Exactly.
Okay, then
That's it.
what we'll-
That's it. So let's try a few more. We're going to try a bazillion more till you're like, okay, I get it, okay? That's why it's totally weird. This is why they put it as a separate section, which is good, because we never did this before. So when it's negative 2/3, you're going to say my new x, my xt, right? My transform x is, so we know in here, that's horizontal. Horizontal, right? So we know that there's 2 things happening here. 2. There's a horizontal reflection, and there's a horizontal, is that a stretch or shrink? Which one is it? Flip it. Stretch, because it's 3/2. This one, is that a stretch or shrink? shrink because it's a third. Exactly. Okay, so we're getting that pattern. So when it's in the bracket or in whatever it is, and we'll do, so look, I'm going to do a squared, I'm going to do a square root, I'm going to do one of every type of the new parent function so you can see what it looks like. So if it's just f, it means general. We don't know what the function is, I'm not telling you, okay? So f means just general function for any, and then that means negative, so it's still going to reflect it, so that means horizontally it is reflected. The reflection isn't opposite, right? Reflection is just negative, but the 2/3 now becomes reciprocal, 3/2 times the x. So we're going to take it and do the reciprocal. So that means it's going to be a stretch by a factor of 3/2. I want you always to leave it as a fraction. Fractions are our friends, right? Don't be afraid of them. I know on the quiz you're like, oh, it's a fraction. What do I do? It's a fraction. Just leave it. It's a fraction. It's okay. So don't worry. And then, like here, leave it as a fraction. Don't change it to decimal, right? Leave it as a fraction. And we're going to sub in the 0.25, right? So subbing in 25, so same thing. That's my x and that's my y. Sub that in, right? And we're going to go negative 3/2 times 2, right? And we know that's over 1. Top times top, bottom times bottom. That's negative 6/2. If you run out of room, go into a new column, so that's negative 3. The y did not change. We will change y in 1.8. 1.7 is just getting us used to this reciprocal idea. Okay, reflections and reciprocal. Literally, that's all it is. Today, all we're doing is reciprocal and reflection. Reciprocal and reflect. That's all. Okay, just to get you, breathe, get through this one. And then tomorrow we'll add. So for now, my yt is just y. Nothing changed. Right, so nothing changed on that one. So then, if you don't want to write the mapping point, you don't have to. You can just say therefore, and then give me your final answer. If you want to do it as a map, you can say that 2,5 was mapped to, you can do it this way, but I don't need you to. If you don't want to, you can just go straight to therefore, and then your answer is negative 3, and this is still 5, nothing changed. Okay? Right, that one's always really hard. The first one's always like, what are we doing? Why are we doing it? This feels weird. Let's try it with every one of the parent functions that we did now, okay? Other than linear. Linear, there's nowhere to sum. Quadratic. So let's try a yes.
Where when you input the x,
Mm-hmm.
it's 2/1. That's almost 1 over
2 is, it's not the slope, right? So it's just the 2. So you put any whole number is always over 1. When you're working with a fraction, you just put it over 1. Yes?
Why do we flip the two numbers?
That is the whole pattern that we were looking at here, right? So that's the whole thing. So when we're doing this, whenever it's in the bracket and you tried to graph it, this is telling us that it's actually shrinking it horizontally.
Yeah. That's what I got.
Yep. Okay? So that's the pattern that we're seeing, is that in the bracket, it's always the opposite of what's happening. So it's always the reciprocal.
So you always need to flip it?
Just for this horizontal one. Yep, every time. All right, try it again. So if I give you a quadratic, and again, don't take it out of the bracket. Okay, I want to leave it where it is. Let's talk about it horizontally. I don't want you to convert everything to vertical. So let's leave it here. If it's in the bracket like that, I want you to tell me what's happening. So for each pair of functions, identify the parent. Why do I have pair? No, each function. So for each function, identify the parent function and sketch both the parent and the transform function on the same set of axes. Okay? Normally, I don't make you graph the parent one as well, but let's practice that a little bit. So the parent function for this one is y equals x squared. Does that make sense? Because you can see right there, it's a squared function, so the parent function is the quadratic. Right? So identify the parent function. Yep.
Would it not be negative?
No. Right? What did you study in 1.3? What were the parent functions?
So negatives are transformation?
Yes. What did you study in 1.3? What were the parent functions? What was our parent function of the quadratic? X squared. Yes, and the negative is the reflection. Okay? Also, we never did a negative in the bracket, so that would still be vertical again, right? So you got to know vertical and horizontal are not the same. Okay, so you can't say negative and then make it a horizontal, and now you're confusing the two. Okay, so that's your parent function. Those are what we said we memorized in 1.3. So we've got that one. Now, identify, sketch both the parent. So what I'm going to do is I'm going to try to go with this little formula idea. If you're okay without doing the formula, eventually by grade 12, I'm like, skip the formula and you can just do the graphs. I think that's what you're asking, if you can just graph it right away, or if you want me to draw it. So you can draw the parent function. So I'm going to draw the parent function. If I don't ask you to, you don't have to show me both, right? So you can just show me the final graph. If I ask you to draw the parent, that means I want to see the parent function. You were asking how many graphs? Yeah. Yeah, so you can. If I don't ask you to draw the parent, you don't have to draw the parent function. Okay, some people just start right with the transform. So I'm going to draw the parent function here, just so you have it, because I asked you for it in the question. But if I don't ask you for it, then it's your choice. So that is y equals x squared. So that's the parent function. It says sketch both. Now I want you to do the transform one. Okay, so for the transform function, I'm going to do the equation. So the equation is this is the idea I'm going to use. Again, by grade 12, you're going to be able to hopefully do it faster without the equation. You're going to be saying the transformations in your head and be able to graph it right away. Some people still like the formula, and that's totally fine. And some people are like, ooh, if I can do a little bit more in my head, can I skip some steps? And that's good. Okay, but now I want the equation. So I want to see some work. I do want to see the steps here. So my parent function graph would be this one. So I take a few of the points so I can get the pattern. I'm going to start with negative 2, 4. Oh, sorry. Why am I writing it that way? Negative 2, 4. Negative 1 is 1, 0, 0, 1, 1.